arranjar uma folhinha para preencher, para mandar por e-mail e entregar o folhinha também. Se não entregar, está ali para o correio. Pronto, era isso. Estava peguem as mãos agora sobre o dinheiro. Em que horas são? Abaixo, só que eu fiquei às 4 rápida. E eu são agora, sabes? É uma daquelas em frente. Eu acho que o programa não. Eu vou juntar o cantor da Maria com o pessoal de Lisboa. Era isso que eu queria fazer. Era isso que eu queria fazer. Eu queria juntar uma coisa para a e ela ontem estava na lista que queria jantar, vai, para me aguentar à prova, não posso tomar mais coisa para a jantar, se é uma coisa mais rigorosa, e os outros gostam de ser. Vamos a jantar. Está bem? O outro ainda fala da Maria. O outro era bom, porque a minha data não era para todos. Eu não posso. Da. Cred că ți explică după aia ce au băgat în ele, știi? Probabil vrea să le ai băgată. Mamă, vreau să
vamos a hacer una explicación de todo lo que vamos a hacer ahí un poquito. Sí. So, ladies first. There you go. Okay. Hi. Sorry for the delay. We all came rush for we all come from a very interesting discussion from our colleagues on drag checking. We are checking. We are a project from Aptus. We do drag checking in service and like in parties. We main focus on colorimetrics tests and thin layer chromatography. The purpose of this workshop is to show us how we do these chemical techniques, as well as to advise anyone that has any kind of doubt on this kind of service. We have prepared some samples on amphetamines, but the service itself is not only limited to amphetamines. We also test cocaine, DMT, tryptamines, phenethylamines, heroines, and so. But for the purpose of making this workshop the most tiny and not boredom for all of you, we're going to provide only service on amphetamines. So, when we started the service, like we get the sample, and then my colleague Kasia is going to explain you a little bit how. She's going to explain you how we proceed with the colorimetric test. On the meanwhile, I'm going to prepare the layers for thin layer chromatography, which I will be explaining to you afterwards. So I'll leave you first with my colleague Kasia, super professional here. So, yours?
So, usually what we do first, when we receive a sample comes to us So the sample comes to us in an ethanol like this, which is now empty. I'm going to put the sample in there. And basically we don't need a lot, we just need very, very little to perform the analysis. So for example, even that amount is already enough to do TLC and colorimetric analysis. So we're assuming that we have a sample of MDMA, and I'm going to take a little bit, place it here. So when we receive the sample, we don't know exactly if the person that bought it knows exactly if it is really MDMA or not, and in order to proceed with TLC, we need to know that it's one of the amphetamines or ecstasy. So to confirm it, we apply colorimetric reagent on the sample, and it should change the color accordingly. I think that's this one doesn't change the color, so we're probably dealing with another substance. Slightly yellow to kind of like dark purple, almost black. So this way we know that we're dealing with one of the with MDMA, but it could be also MPA. can also check amphetamines. Yeah, that's the standard test you can even do at home. You can even buy those reagents. They're available, widely available, and perform this kind of analysis at home. But as I said, it's very limited because it only gives us confirmation that we have the substance. It doesn't say us anything about possible adulterants. So that's why it's only the first step, and that analysis will show us if we have any other substances present.
Okay.
It's good to do more than one test, right?
Yeah.
Like you say it's BMPA, MDMA, DXM. So if I use after other reagent, I can say it's MDMA, not MDA, right?
Yeah.
Yeah.
You have to, of course, each time you do a colorimetric test, you need to do it on a clean sample itself, because colorimetric reagents itself, they react between them, so you need like an extra piece of sample. The more information you get from a different colorimetric reaction is going to be good, but then as being a type C analytical method, it's better to confirm the presence of adulterant itself with TLC, which is what I'm trying to do now.
So, for example,
The amount that I use, I can use the same amount in colorimetric, not in TLC. It's the
no,
same.
you have to split it in half. Like, for example, this is the amount I can use for both even, because I just need a tiny amount to apply the colorimetric reagents, because it will change the color anyway. And then, in order to apply it for TLC, I'm going to add a little bit of methanol. And we lost our pipette, so I'm going to do like this. So we dissolve the sample in methanol.
What's that device?
It's called vortex. It's basically just for stirring the sample.
Okay, so
Okay, no worries.
okay, so I'm going to explain you what I'm doing. The advantage of thin layer chromatography is that we use this technique to know the adulterants that are present on the powder that my colleague analyzed. For sure we know that it's MDMA, but that doesn't mean that it's only MDMA. As in colorimetric reagents, normally the compound which is in the higher concentration is the one that reacts. Meaning, as an example, we don't know yet, this sample could be perhaps 45% MDMA, 40%, we wish not, PMMA. So, by doing this test, we don't know if PMMA is in there, unless we do a colorimetric test specific for those. So, the step to know whether this hypothetical PMMA or any kind of extra adulterant is present on our sample, we're going to do a type C analytical analysis, which is called thin layer chromatography. Here, we're going to use a plate where we are going to place our samples. But how are we going to know what do we have on it? It's quite obvious. What I'm doing, I'm setting up different standards on the side of the plate as MDMA, amphetamine, 2CB, MC methamphetamine, MCPP, as well as some adulterants, paracetamol and caffeine. We could put a lot of them, but we have a not so big chamber. By doing so, just for example, setting up the last one.
And also there are some adulterants that don't react with the reagents, like paracetamol, for example, or caffeine. We won't be able to see them here. They don't give any color change.
And what we do here, for the preparation of this technique, we're speaking about microliters. We're using, like, as you see, as you may perhaps see, if you can pass it around. It doesn't seem so, but there's a really tiny hole here that allows us to get our liquid to prepare the plates. So now I'm setting up the standards that I'm going to use to try to recognize the substance present on this sample. Set it up slowly. Okay, everything is done. Okay, and the plate will get something like this. Now on the side we're gonna stick, my colleague's gonna stick the sample that she has prepared, and what we are going to do afterwards, we're gonna put it in a chamber. What do we have in this chamber? In this chamber we have a solvent. What it's going to do is going to go up the plate, and it's gonna take the samples, that's gonna be here, and the standards, and they are going to go up. How do they do that? This is based on two main chemical concepts, which are polarity as well as molecular weight. If we could be talking about it like in a very deep way, but I don't want to bore you. Let's say that each compound has different molecular weight as well as different polarity. We take a solvent that has similar polarity, taking the principle that the polar things dissolve polar things, something more or less. It's in Spanish, but the translation is really bad. And what it's going to do when it goes up means that the components are going to be in different height. For example, it's like, hey, I saw you have like MDMA and amphetamine on the same spot. They're gonna be the same height. No. Why? Because they have different polarity as they have different molecular weight. In our case, amphetamine, as being more light, is going to be on the bottom part. And MDMA, as methyl-dimethoxymethamphetamine, is wider, so it's going to remain high. Meaning that when we let it up till this point, we are going to have different spots with the different compounds that there are on the sample. Afterwards, we will have to let it dry a little bit, and then we do a relation with UV spectroscopy, well, UV lamp, to be able to see if we have only one spot on our sample, meaning we only have MDMA, bingo, or we have some extra ones that we may try to recognize with the standards we had set up. So, you want to put the sample? Sorry. Nearly 10 of each. That's too much. I think we're not going to need more. I suggest you keep your breath a little bit because we have ammonia in this solution, so yeah. It's like we're gonna do it really, really fast. 1, 2, 3. Okay, so as you may see, the solvent is going through our plate, silica, and it's going to start going up slowly. Like 15 minutes slowly, 20 seconds.
So now we have 15
now
minutes
we have the
questions.
time to answer all the kind of questions, as well as giving any kind of advice that you may be interested in.
I have a doubt in the solvents, right? Because we out a kit, you use TLC with the bank police kit. Then I didn't see what's the solvents to use all the drugs to solve all the drugs. What solvents do you use to do this technique in TLC?
So like for TLC, for amphetamines, we use methanol with a little bit of ammonia.
Methanol. Please, methanol. Yeah.
You have it written here, like
Right.
it's methanol, and 0.75 milliliters of ammonia. So just like 1 drop of ammonia.
Right.
But still it's very strong. Then for ketamine and cocaine, we use 2 chambers because they have like different polarities. So one chamber would be only with methanol, and the other one would be with acetone. Yeah.
With LSD or MDMA?
We don't do colorimetrics with LSD. Like we can do TLC with LSD. Yes.
Yeah, the thing is like with the funny thing about LSD is like apart from being such a compound it has a little, you can do a little trick with LSD. That is like in methanol is the only substance that is like fluorescent. That meaning is like it was pretty useful when we were dealing with the epidemic of embalm, and we were dealing with embalm and LSD. For sure, like a TLC and a colorimetric is like kind of useful, but like for doing it on spot, we do know that ethanol and methanol with sample of LSD is fluorescent. While on the
And LSD itself is fluorescent, so you can basically, if you have a blotter of LSD, you can put it under UV light, and it will be fluorescent. And for example, 1P LSD is not fluorescent.
But in TLC we can use methanol, right?
I don't remember how it should be analyzed, but I think it's actually.
yeah, mostly all kind of amphetamines and derivatives, and so mostly of illicit drugs, they are soluble on methanol. Of course, their solubility depends and varies a little bit when we're dealing with more extrapolar solvents like ethanol and so whatsoever. But the most common use is methanol, also because it's one of the cheapest, which is also really nice. But we don't forget that methanol is kind of heavily toxic, so we have to be very careful regarding like the contact with the skin and so on.
Right. What is this
Gloves?
glove exactly?
Yeah, like it's for protection because like the reagents.
No, right, I know.
That's nitrile.
Yes.
Nitrile.
Yes. Normal, you buy the pharmacy.
You can buy it in the pharmacy. Yeah.
Right.
And it's because all the reagents are concentrated.
No, I already
So you have to be very careful with them.
So we still are like 25% of it. So any extra questions perhaps? No? Like
Well, what
Do you
else?
also bring all these things to festivals and clubs, like so many? Like,
Yes. Even more because now we lost some things. Like when we were making, like we moved all the things here and they lost some very important equipment. It was a bit improvised, but yeah, if we go to festivals, we usually have like a tent, and it's separated from our stand that has like flyers and
yeah, you can do everything. But like
basically, yes, we
wait,
have all of
finish.
this.
No pasa nada.
The little fridge where we store the reagents and the standards. So yeah, when we go to festival, we take
what do you do
everything.
with drugs, like with leftovers? I mean, like what is left? Like for example, there is like chemical reaction. Yeah, here as well. So do you like throw it?
We
Or?
dispose it, yeah.
Okay, but I mean, like you are giving it to the police, because sometimes people give you not like the small amount, they give you all the pill, let's say, yeah. I mean, sometimes it happens, right? Like, they give more than it's needed. So what do you do with that part which is too much?
Regarding the part that's too much, sometimes it's a good thing to keep, if we have some extra, to keep it in case we need to do some extra analysis, perhaps something happens and so. And also, we can take into consideration that the amount of samples that, for example, imagine we deal with this and we still have nearly half a gram. That half a gram can help us do any kind of formation or workshop to any kind of volunteers that are wishing up to know how the system works, or even, for example, to doing like any kind of test method development that we may do, perhaps on like solubility or any trials. As you may know, these selected samples are hard, and like, for example, to get an MDMA like on a certified lab is like nearly 100 euros, something like that, for 99.99. So having this extra seizure can have like a lot of possibilities. But it doesn't go to the police, it doesn't go to our pocket, it stays like for research and development and quality issues.
So sometimes when we find like pure substance, we can use it for analysis to make the standard out of it.
Just it's a little question. In this chamber, right? I can put 2 or 3 flat plates.
Usually the plate is a little bit longer, but yeah, like if you want, the problem is like it's better not to disturb the plate that is already inside. So it's better to run one analysis at a time. Of course it's possible, but it's better to do one per time. And you can have like longer plates where you just like apply the standards at the beginning, and then you can apply many samples. Yeah.
Imagine like plates. Sorry. Plates are normally like this big. It's like,
So we cut it in half.
Right.
it's not like this big. So yeah, we cut it in half and we put it inside. Of course, for example, if we're doing a plate with amphetamines, that allows us the possibility to put, for example, 2CB, DMT, and DOP, like a lot of compounds. But just think about it. For each sample that we are going to do the analysis, we need a standard as well as the standard of the adulterants. So that's what I was referring when we could have like a really long plate if we put all together. But since the plate is set it up to be able to be done in mostly 15, 20 minutes, something like that, it's like it's a good rhythm. So while in case we had more samples, now what we will be doing is like we were preparing another one. So meaning that when this one finishes and we are seeing the results of it, we can leave the other, start running, and in the meanwhile doing the interpretation of the results and whatsoever. Also, an extra thing what you can do when you finish like the TLC, it's like even though you have done it before, like the colorimetric test, you can do an extra colorimetric test at the end. When the plate is dry, and you have known, okay, I have my spot here, I have my spot here, we have seen with the standards that what it is, and we can do an extra colorimetric test to verify again that our sample of MDMA is sure MDMA after doing twice and even a third technique, and also to see, for example, hey, I see this tiny spot, I'm not so sure if this is adulterant or so whatsoever, so we can do a colorimetric test to see, it's like, okay, we don't know what it is, for example, but we know this has like this kind of color. Perhaps with other advanced techniques like high-pressure liquid chromatography, gas chromatography, would be able, with that sample that we kept, that, as I told you, it's like perhaps we can use it for another thing. If so, it's like, hey, we have something here that we don't know what it is. It can be dangerous or so. We can keep that and take it like to any kind of certified lab which has gas chromatography, HPLC chromatography, to go further and say, hey, this some part that we don't know what it is this compound. And we do know that when we treat it with a colorimetric test, it's this color. Of course, we have to do it afterwards, because as I have said, when we do colorimetric test, it only reacts the one that is in the on the higher concentration. What else? Okay, we're half to it. We're half to it. And it's a little
yeah, but then if we apply it on the plate, for example, if we have a spot that is on the height of MDMA, and then we apply colorimetric, and we see that it changes the color to dark black, we can be almost like 99.99% sure that this is MDMA. And the same for amphetamine. If we apply amphetamine, it's on the height of amphetamine spot, and we apply colorimetric, it turns orange, we can see that it's probably amphetamine. So we have like double confirmation, which is
So then, we can speak a little bit if you want, like of advantages of this drug checking. We're not going to speak again as our colleagues did a really nice presentation, but we can say that for risk reduction services, as well as for people that may work in drug consumption rooms, it's like a really useful tool, because we are able to get information about the samples or the partygoers and the consumers are getting. And with a little investment at the beginning with colorimetric tests, only for getting like the reagents itself, we are able to start slowly to giving this type of services. Of course, it has its limitations. We cannot say that we cannot see adulterants. We need like there's like a whole set of reagents to be able to do these tests. But it's a first step. Then we can go even further, getting thin layer chromatography, which in investment 2K.
yeah.
Between 1 and 2,000 euros, like you would be able like to get like nearly.
The most expensive part of TLC are those plates, because they are made from silica and aluminium. Silica is toxic, by the way, so you shouldn't touch it without gloves.
And the standards.
And the standards.
And the standards. Because in case you don't know, if standards, they have to be pure, like really pure, like. And if you try to buy it on several houses, you can get like 99.99 and a lot of 9% purity compounds, but they ain't cheap. Well, the one of amphetamine is really cheap, but others, if you try to get, for example, the standard of DMT or so, you can easily live like 100, 200 euros. And okay, if we're doing very advanced techniques, it's really good to have these compounds. But for example, compounds that they are not so commonly found, for example 6-ATB or any kind of compounds that are not so weird, getting all the standards, it can be like a harsh investment. So normally when you're starting for TLC, you go for the compounds that you are going to test the most. Amphetamines, cocaine, it's different say adulterations. So within the range of that 2,000 euros, you would be able like to give results of the most used substances that are on the street. Of course, not all, because we find all kind of products. But within that range, it will be able to grow like a full lab. Of course, that would be the material, and then it comes the point of like, hey, okay, this seems to be a little bit hard. I don't have any kind of scientific background. The good thing is like colorimetric and thin layer chromatography is very friendly. Like you can have like how to say 2 hours workshop, and I tell you, you would be able like to do not exactly the same as us, but you would be able to do pretty much okay. Of course, this is a very common technique in chemistry, in biochemistry. So there's a lot of books that explains the principles about this technique, as well as how to do it efficiently. And then, if you wanted to go another level and you have really a lot of money, We could go into high-pressure liquid chromatography coupled with mass spectrum, or gas chromatography coupled with mass spectrum and another mass spectrum, why not? But we are speaking of equipment in the range of second-handed and being likely between 20 and 30,000 euros. Yeah.
How much you applied on the plate, and well, it's kind of sketchy, I would say.
Yeah.
And it's not so widely used, like
No.
especially in treatments.
To be honest, I have only used one, and it was like for cannabis. It's like to get like mainly the principle of percentage of CBD and CBN, and but couple the quantification with this kind of samples, I have never done it, and it's better to do it with gas chromatography, high pressure liquid chromatography. That there we can see even the tiniest amount of any kind of alteration. And also as well, that I forgot to mention, there's a middle step between the 2000 and the 20,000, like very middle, that is infrared spectroscopy. Here, with infrared spectroscopy, it's like actually like this big, something like, well, the old ones are really, really big, but within the range of, for the equipment itself, maybe 2,000 euros, and then a database, because we need a database. We don't use standards, that can be around 1 and 2,000 euros. You would be able to even like do quantification and qualification analysis. Infrared spectroscopy goes on another way. It's like we have the equipment, we have the powder, and what we do, the machine reads the sample and gets some spectra. Imagine you have your line here, and it has like different lines up there. And the thing is, like, each compound has a specific spectra. So what you do is you make a comparison with your database that you have bought, and it was quite expensive because it has a lot of compounds. And with this, you are able to do this kind of techniques on the middle of nowhere. You just need a plug and a laptop. And like, so as you can see, analytical techniques can go extremely, extremely complicated. But starting from low and from scratch, going upwards, we can have a lot of varieties that give solutions to nearly all types of pockets. And so, being the first step, colorimetrics, and then TLC.
Also, like, the advantage of infrared spectroscopy is that it doesn't require any sample preparation, and you don't need to know anything about chemistry to put the sample there and just press the button, and it will read the spectrum and tell you what's inside. And there's also Raman spectroscopy, which is kind of like colorimetrics. It just gives us information about the most present substance. So it's not very reliable also, but it's good to use it in field. Like, it's a very small device like this, and it's like it gives a beam of light that goes through the sample, and it will tell us like what's the most present compound in the sample. And it's good in countries like when even touching the illicit substance is a crime already, because it doesn't require any interaction with the sample. So you can have your machine, the person can have even an Eppendorf like this. The light goes through it, and it's like you didn't touch the sample at all. So that's like some kind of a solution, but also it's not very accurate.
And do you use like fentanyl strips to check if there is any fentanyl in the substance?
We have fentanyl strips, yeah, but because we're dealing with party setting, we don't really get to like opioid users. So it's a different context. We go to festivals, to electronic music festivals, so we don't find many people asking about opioids, about heroin, about fentanyl.
Yeah, but I just heard about a few cases when in MDMA the fentanyl was found as well, so you know, that's why I'm a bit
I've heard
curious.
that about some colleagues of the States, that since now fentanyl is like nearly replacing heroin as like having such a huge impact. I have heard that they have even found samples of cocaine, MDMA with fentanyl. To be honest, I don't think it's something that is commonly found here in Europe. I hope yet, I hope never, but you notice the demand. It's like, to be honest, like the situation that they're facing out is a little bit as the one we had like nearly 4 or 5 years with the NPS and the catenones and whatsoever. Not so deadly, but we're able to find some of those compounds, not only on legal highs, but sometimes mixed with other normal, not to say normal, but frequent substances, MDMA and amphetamines. But as my colleague said, remember that we are dealing on a scenario of drug parties. It's like the 90s scenario was completely different from the 80s. It's like if the 80s were heroin and opioids, the 90s was the boom of MDMA, 2CB, and ketamine, and a lot of stuff. And also it has to be with the age. I think part of the youngsters and the generations, they are quite afraid and quite shocked of what it was before, and they try to remain a little bit away from that. I'm not saying that this is like always like this, because to be honest, when I was in France, I had the situation of someone coming with heroin, but it was only once in half a year. But it happens. But normally, it's not something that we find so much.
But do you have, like here, for example, reagents to test the heroin or something? Like, are you testing here as well heroin? If somebody would come in the party and they said, like, you know, I would like to check my heroin. Like, could you do it? Like, do you have?
I think we can test it with reagents, yeah, but we don't have the standard for heroin. But another thing that reagents are good for example, in case when you have a lot of catenones, like in Poland, in Ukraine, in Czech Republic, it helps you to distinguish more or less, like, if you have that MDMA or amphetamine, or is it a catenone?
I think there is a way to get fentanyl with colorimetric tests. I don't remember if it's the video in the backboards, I don't remember, but we have our material that we take here and have a way to take it up to fentanyl. I don't know what they think, but...
yeah, because like this strip, they work like basically like colorimetrics. Yeah. Because you dissolve the sample in water and then you put the stripe inside.
I stayed with colorimetric. I take this because if I have a hypothesis in colorimetric, I will...
Also, as our colleague said, it's like if I don't have this technique, I use another. Regarding analytical techniques, colorimetric is like a type C, and the thin layer chromatography is like a type B. There are some requirements to be able to give, like, how to say, reliable results. I'm speaking now about quality control and quality assurance. It is possible to make your results reliable on an analytical way. It's like, for sure, it's like the more advanced technique you use, the more reliable your results are going to be. But if you couple techniques, for example, colorimetrics, with thin layer chromatography, and then we are able to do an extra FTR, then you can even like present results like, no, this is no joke. It's like, I have done this analysis of this sample with these 3 different techniques of different, like, how to say, specification technique. So this allows even like NGOs and other services to present their results to high-level institutions, because the combination of those different techniques makes them reliable. So, meaning that an investment on the lab makes possible to present these different results to any kind of organization, ask for funding, and whatsoever. And we should get out of there. Maybe like take it out and we check it out. So thank you for waiting.
We're almost done.
Thank you for waiting. I know that I'm very annoying when I talk. I'm sorry. So now that we have taken our plate out, and you have waited, we need to dry it out. For this, we need a ventilated area to
Yeah, it's just a lot of like
yeah, and to eliminate the excess of solvent to get it dry. You can use, like, even if in some cases you can use like a hair dryer. Sorry.
Also
You can-
in the lab we use it like to dry the plates.
we can use a hair dryer and so, but also we can, for some substance we have to take into consideration that if we heat it very close, they can just go away because some compounds are very volatile. Also, what we are going to do, read the plate with a UV lamp. There are different methods that, for example, we wouldn't need to dry it out, and we could use like another kind of revelators, but that's another kind of story and mostly focused on organic chemistry. But just letting you know that there's like a whole way of doing this kind of things, like even in the sample preparation, even with the solvents, even with the plates, because just 20 years ago, these plates, they were made of paper, and now they're made from silica. So you can see how everything is constantly evolving.
Okay, so that's our box with UV lights. It's dark.
It's black. We're not racist here.
Because it needs to be dark. Okay, so I'm gonna see what's on the plate.
This is
and
UV lamp.
I'll mark the spots.
Yeah.
And then I'll let you all see it.
It's like it's a chamber, and sorry. We have the UV reader. We can select, well, normally this one comes with 2 wavelengths, I think.
Yeah, it has one.
And this is like the most important things, like the lamp is over there, and I don't know if it's on or not. Of course, when watching the, I'm gonna get you a pencil. Okay, cool.
You can also put like a black thing on the head, no? So it covers all the light coming from the sides.
Do you see? Pedro, ponle una sudadera algo. Se ve.
¿Se ve bien?
Se ve bien, gracias.
I think we put a bit too much ammonia because they are very high and very close to each other.
My bad.
No worries.
Okay, so anyone that wants to see is like €1. Nah, I'm joking.
Okay. One
So-
thing, you just need to use the glasses. Okay.
How do we do it? Maybe.
But yeah.
So, you need to put the glasses, or your eyes will burn. Nah, joking.
You can see the spots?
On the side, as we said, on the side of the left, we have the standards, and the side of the right, we have the sample that we were preparing. And as you may see, it's a bingo. We don't have PMMA or any extra substance.
But if it's just one spot, it means you're...
Sorry? With this technique, we can. Well, we could, but it's not very. We could, but it's not very accurate. If we want to see like the concentration and the purity, we would need to use advanced machinery, like maybe perhaps gas chromatography, hypersoliquid chromatography, and also to what else? Mass spectrum mostly. Yeah, indeed,
It's not the
indeed.
best plate because the spots are very close to each other. I think we use too much ammonia.
But even like, for example, if you make an intermediate investment on infrared spectroscopy, I think you are able to develop like quantitative methods for infrared spectroscopy that are not so expensive, but it's kind of a hard work. Sadly, for the moment, sorry, gas chromatography remains the most reliable way to get your concentration, because also when we speak about knowing the concentration of a substance, we mostly think about the one that's on the highest. But as sure, it can be one of the lowest also. Because I can put as an example of some colleagues that say, hey, we have this machine, we are analyzing samples of heroin with fentanyl, and we have an issue that we cannot detect samples with less than 5% of fentanyl.
5%?
Of fentanyl.
Yeah.
What? Now there we go.
That would be a hell of a lot.
It would be still, it would be still a hell of a lot. But then it's like, we should go further into what's called test method validation and analytical research and development. We should change the limit of detection of the method to do quantification. It's like a long process to deal with it. But in the end, at least we know that the substance is there. We may not know the concentration, but this is like some of the challenges, like advanced challenges that we may focus when we are dealing with quantification of this kind of compounds. Because it comes to a point that we have also to deal with the limits of the machine itself. Yeah. The machines, they are not like, they're not panacea. But it's like
before the machine was just, drops of that and drops of that.
And now it's like big machines, like with like nearly all.
I've seen the loot. They have a machine for millions.
Anyone? For the photo?
That's fine. Thank you.
Has everyone seen it? I do some research.
This is Marquis. It's Marquis, yes.
I've been doing technology.
So you can see the spot is turning black. Here, as we have samples of MDMA and
this one amphetamine.
yeah, the orange one is amphetamine, and this one is MDMA. And you can see it's the same height and the same color. For example, here we have 2CB, which it should turn a little bit green, but I think the concentration is too low.
Amphetamine.
Methamphetamine. Yeah.
That are written and all the substances contained in that sample.
No. They were already on the plate.
No, my God, no. MDMA, amphetamine, 2CB, methamphetamine all in once.
It didn't
Well,
come
maybe.
out really nice, but you can see the MDMA.
Maybe.
And it's like
You never know,
above we
that's
have
for sure.
amphetamine.
Also a little bit of amphetamine. There is that or no?
This is 2CB.
Not sure.
This is methamphetamine. This was a drop. And these ones, I don't think they will even show any color with the reagents. What?
So we can say that there's MDMA.
In our sample there was MDMA, yeah.
Only MDMA.
Only
Yeah,
MDMA.
it's like, as we say, it was like a bingo. It's like someone got really lucky and has like MDMA with no higher quantification, but of sure there are some things that perhaps we cannot see there, as like, for example, the colorant or the lactose that are on really, really low concentration. But of course, if we have like advanced techniques of chromatography, we would be able to say, but we know that it doesn't have